Welcome back. Today, this is so exciting. We're finally going to use all these things we've been working on, and we're going to learn to multiply big numbers. Now, you might have learned this in 3rd grade. You've definitely been introduced to the concepts, but we're jumping up to a 4th grade level, and it's going to be fantastic. Today, we're going to use an algorithm called the partial products method. Remember, an algorithm is just a fancy way of saying a method for solving a problem. Now, if you talk to your parents and you say, I multiplied with the partial products algorithm today, they'll either be really confused or think you're really smart, or both. But if you ask them for help, they might end up scratching their head. This isn't the way your parents learned to multiply. This isn't the way your teachers learned to multiply back in school. This is what they call a low-stress algorithm, meaning the traditional way of multiplying is fantastic. It's easy, it's fast, and it's lasted for generations. But if you make a little mistake, then the whole problem can be thrown off, and there are certain steps that are hard to remember. We're going to learn that one soon. I think that's very important. But in the meantime, this is one that's a little more flexible and gives you a few more options for how you approach it. And it's a little more forgiving if you make a mistake. It's easier to spot your mistakes. Now let's do a quick review. These are things that we have worked on and that you should have mastered. Multiplying by zeros. Remember, if we have 60 times 90, we simply do 6 times 9, and then we count the zeros on the left, 1, 2, and we add that many zeros to the right, 1, 2, and that's how we get our answer. Expanded form, remember we worked on that. 124 is the same as 100 plus 20 plus 4. These are the things we've worked on the last 3 days. And extended facts, if 5 times 3 equals 15, then we know that 50 times 3 equals 150. Because remember, if you add a 0 someplace on the left of the equal sign, you add a 0 someplace on the right. Now, we've worked on those, you've practiced those, and you've mastered those. So now you're ready for partial products multiplication. But first, here's the tip. Here's the big idea. Breaking big numbers into smaller numbers can help you multiply them. So if you get something like this, 56 times 98, and you're thinking, kiddo, what? Remember that you're really dealing with 50 and 6, 90 and 8, and you're just going to be multiplying smaller numbers. So let's get on with it, and you'll understand exactly how that hack works. I'm going to introduce the partial products method. You can also see the example in your journal for how to do it, and if you look in your student reference book on page, let's see, 18, I think, 184, those pages will tell you how to do it too. So what we begin with is taking that top number, 263, the bigger factor. And when you're setting up a multiplication problem, the bigger number always goes on top. The larger factor goes on top. It's just easier. It doesn't make it right or wrong, but it makes it a lot easier. Let's switch colors here. So we're going to take that 263 and we're going to turn it into expanded form. Remember that means we turn it into 200 plus 60 plus 3. That's why we were working on that. And 4 doesn't need to be changed because it's already just a single digit. Now, each of those numbers on the top, 260 and 3, is going to be multiplied by that 4. So we're multiplying 4 by 263, but we're going to make that easier by multiplying 4 by 200, and then, let me use a highlighter here, 4 by 200, then 4 by 60, then 4 by 3. Here's how that works. Okay, so we'll start with this. We'll take our 4, and since there are 3 numbers we're going to multiply by, we're going to put 4 down here 3 times. And then we're going to put our little times symbol, and then we're going to list those ones that it multiplies by. 4 multiplies by 3. We'll start with that. 4 multiplies by 60. 4 multiplies by 200. It doesn't matter if you start with the bigger number on top or the smaller number on top, as long as you follow a pattern to make sure you don't miss any. You'll see that I also drew these little loops so that I made sure I didn't miss anything. By now you know I like to include all these little steps because it helps me keep track of what I'm doing. And then over here, this is a little different. We're going to put our equal signs to the left, and we're going to write the partial products. Now, one tip that will make this a lot easier for you is if you keep things lined up in place value columns. Lining up your numbers is always helpful, especially when you're doing a new method like this. So 4 times 3 is 12, so we put the 1 in the tens place and the 2 in the ones place. 4 times 60. Remember, we're going to use that multiplying by tens rule now. We do the 4 times the 6, and then we add 1 0. In this case, we'll add the 0 first. And then we know 4 times 6 is 24. Same thing down here, but we know we have 2 zeros. And then we have 4 times 2 is 8. So now these are what we call partial products. A product is the answer to a multiplication problem, and these are called partial because they're each a part of 4 times 263. If we add them together, we get our full product. And if we've done this right, the adding should be pretty simple. So we just add the ones, we get 2. We add the tens, we get 5. And we add the hundreds, and we get 10. So our answer is 1052. Now how do we know if that's a reasonable answer? Well, before we started, we should have made a magnitude estimate. Let's do that now. 263 is about 300 times 4. That would be 12 with 2 zeros. So our estimate should be in the thousands. Is our answer in the thousands? You bet it is. So based on that estimate, this is the right answer. The way to double check is to take 1052 and divide it by 4, but we haven't worked on division yet, so don't worry about that quite yet. If you want to double check, you can always do the whole problem again. That is always allowable. Now this is as big as we're going to get today. 4 digits on top times 1 digit on the bottom. Let's try it again. I'm going to just let you do the expanded notation, or the expanded form. Go ahead. Oh, you forgot how. Okay. Remember? 1,000 plus. So you write the rest of it, and then I'll catch up with you. Okay, looks like you wrote 300. You're having trouble. Okay. The tens is 20, and then, yep, there's a 6 left over. Wow, that's a lot more than before. That's 4 digits. And 7 is just 7. Well, remember on the last problem how we ended up writing the 4 3 times because there were 3 things we were going to multiply it by? Well, this time it's a little different because now we have 1, 2, 3, 4 things we're going to multiply the 7 by. So to get 7 times 1,326, we're going to multiply 7 times 1,000, 7 times 300, 7 times 20, 7 times 6. So there are 4 partial products. I'm going to put little equal signs here, and then I'm going to do that handy thing. Now if you have graph paper, and on the journal page, you're going to notice on the second journal page, they actually provide you with a whole sheet of graph paper. That is the way to do it. If you don't want to use that, or if you don't have graph paper, a great way to do this is to take a lined piece of paper, turn it 90 degrees so you have columns, and use those lines as columns. That's a little math hack too. Okay, so let's do this. Let's start at the top. 7 times 1,000, well, we have 1, 2, 3 zeros. I like to load the zeros first. Make sure we get everything lined up. Then 1 times 7 is 7. The next one, let's load those zeros first. How many? You got it. 2. What do I put here? 21? You got it. How about the next one? 1, 0. What's 7 times 2? You beat me to it. 14. And then 7 times 6? 42. Okay, there we go. Those are our 4 partial products. We add them together now. Add the ones and you get 2. Add the tens, you get 8. Add the hundreds, you get 2. Add the thousands, you get 9. Is this a reasonable answer? Let's do an estimate. We're going to round 1,326 to 1,000 times 7. So the answer should be around 7,000. In other words, the answer should be in the thousands. So if I were to circle one of those boxes on our estimate charts, I would circle the one that said thousands. Is our actual answer in the thousands? You bet it is. It's not that far from 7,000, so it's probably right. Looks good. Here's a little chart showing you a different way of thinking about it. I was having you write 6 times 800, but another way to think about it is that that is 6 800s. So when you're multiplying that 6 by the hundreds place up here, you're multiplying it by 800s. We've talked about what the 8 in the hundreds place means. It means 800. And this is just 6 800s. Like, hey, how many 800s do you have? Oh, I've got 6 800s. How about you? Oh, I don't have any. I was just wondering. That kind of thing. So I was estimating at the end, but it makes sense to estimate first. Regardless, estimate at some point to make sure that you have an answer that makes sense. Because otherwise, if you make a little mistake, it can throw everything off. Now make sure you have your journal open now to page 118. This is one of those strange lessons where the math box comes first. So the math box for this lesson is actually on page 117. We're going to skip it over for now. You'll go back to it in a moment. But for now, let's look at this. The directions say, and I will help you, I will highlight, multiply using the partial products method. Well, that's the way we just went at. Oh, look, right there. If you're having trouble, look at page 18 in your student reference book. Show your work in the computation grid on page 119. It looks like this. And wouldn't it be nice to be able to put a digit in each of those boxes and keep it lined up? Oh, it would be so nice. So we're going to do that for some of these. So let's start off with 82 times 3. 82 times 3. Let's jump over here, and I'm going to zoom in. First, 82 times 3. Let's make an estimate. That's about 80 times 3 equals 240. So I'm going to write estimate. So our answer should be in the hundreds, around 240. And then, okay, this is where you come in. What do we do next? This is where your brain starts farting, I know. Now we do the expanded form. 82, we rewrite it as 80 plus 2. What do we, oh, you're right. Now we write the 3 down here. How many partial products are we going to have? I'll give you a shortcut to figure this out. Count the number of digits on top, count the number of digits on the bottom, multiply them together. 2 digits on top, 1 digit on bottom, 2 times 1 is 2. So we're going to have 2 partial products. So we have 3, sorry about that. Little equals. In different colors, you're probably just using a pencil. That's just fine. I just want to make it clear so you can see what I'm doing. What do we, yes, you're right. Now we put a little multiplication symbol, a little time symbol for each one. And what do we put next to that? That's right, we list the 2 numbers from the top. So we have 3 times 80, and then we have 3 times 2. Some people call this multiplication wrestling, because the number on the bottom has to wrestle each of the numbers on the top. If you don't follow wrestling and you don't know about tag teams, then that won't really mean much to you. But if you do, then each partner on each team has to wrestle each partner on the other team. It's kind of how this works. So now we solve these. 3 times 8 with a 0 at the end. So there's the 0. 3 times 8 is 24. And then this bottom one is 3 times 2. So now we have our 2 partial products. 246. Look how close that is to the estimate. So I think we did pretty well. Since we're doing our work on another page, I'm actually going to put the problem number here so that if I have to look back, I can easily tell which problem I was working on. I already forgot the answer. 246. Now how many of these do you have to do? 6 of those. And then we get to the estimates down here. Let's jump to the next section. Estimate whether your answer will be in the tens, hundreds, thousands, or more. Write a number model to show how you estimated. Show how you estimated. Circle the correct box, then calculate the answer. This is something we didn't have to do before. We were just doing estimates yesterday. Now we're going to calculate the answer too. And we're going to show that work on the grid on page 119 too. I'm going to help you with this first one because this is new stuff. These ones up here, number 2, 3, 4, 5, 6, I'm going to expect you to do those on your own and then check your work. In the slideshow, there's a sheet that shows the answers. And then when you come to math group, you'll be able to ask questions and get a little help if you need it. So let's jump to number 7. China has the world's longest school year at 251 days. I think Minnesota has 170 something days. Oh, almost 180. How many school days are in 7 years? Do we have to know how many days are in a year? No. We know that in 1 year there are 251 school days. So we're trying to solve 251 times 7. Now for our estimate, we're going to write a number model. Remember, for the estimate, you're going to take each of these, and if it's a double digit, you're going to change it to a number that's easy to do in your head. So we're going to take 251, round it to the nearest 100. Now you could round it to 250, but that's not easy to do in your head. The goal of estimation is to round to a number that you can easily do in your head. Remember, that was yesterday's hack. So we're going to call that 300. And remember, if it's a single digit, you just leave it. So this is our estimate model number, or number model. So we have 2 zeros, pop, pop. And then what's 3 times 7? You know your multiplication facts. 21. We put in the comma, 2,100. That's our estimate, which is in the thousands, so we circle this. Now this is what we didn't do last time. Now we have to calculate the answer. That means solve the actual problem. So where do we do that? We take this and we go to the next page. 251 times 7. Now this is question 7, I believe. Yes. So I'm going to write number 7. Oops. 251 times 7. Is that right? Yes. That's a lot of school days. I love y'all, but that's a lot of school days. Okay. Then we do expanded form. That's right. I want you to do this too. If you're not on page, what page is this? If you're not on page 119, open your journal. Come on. Get off your butt. Open your journal. Okay. 200. That's right. Plus, that's right, 50 plus 1. Okay. And then the 7 goes down here. Now how many things are we going to multiply? How many partials? 3 times 1. That's right. 1, 2, 3. So what do we do next? You remember, we write 7 down here 3 times. I'm sorry, that's not times. That's where we put our equals. So 7, let's do it like this time. 7 times 200. 7 times 50. 7 times 1. Okay, and let's keep things lined up in the columns. Let's do 7 times 2 with 2 zeros. Pop, pop, pop those zeros over here. This is why the grid paper is so nice. It allows you to keep things really lined up. And then 7 times 50, we'll just add that 0 first. And then 7 times 5 is 35. Yep, I know, I'm doing your work for you, but you should be doing it while you watch. If you need to, press pause and then come back. So now I want you to add this. Go ahead. I'm waiting. 1's place, 0 plus 0 plus 7. Okay, you did it? Good. That's 7. 10s. I'm waiting for you. 5. Feels weird talking to my iPad, but I know you're listening. 4 plus 3 is 7. And then we bring the 1 down. Now what was our estimate? Our estimate was 2,100. And this is pretty close. They're both in the thousands. So this is a good answer. 1,757. We go back over here. 1,757 days of school. And then we're done. We made an estimate. We circled our estimate with a model number. And then we calculated the actual number of school days, the actual answer, and we wrote that down. Okay, now you're going to do the next one. You're going to do number 8 on your own. And you're going to check the answer on the slide that has the answer key in the slideshow. And then remember, if you still have questions after that, you can either look at page 18 in your student reference book, or you can come this afternoon and talk to your teacher, or send your teacher a message at any time for help. And then number 9 is a bigger question. Explain how estimation can help you decide whether an answer to a multiplication problem makes sense. Now, what if? I guess that would be a good opportunity. What if, on this problem, we goofed? And I'm just going to back up in time for a second. This is imagining. Imagine that over here we did 7 times 20 by accident, and we wrote 140. Okay, this is wrong, that's why I'm doing it in red. And over here we had gotten this, 497. And then we went over here and we wrote 497. Well, it seems fine, but then we look at our estimate, which is 2,100, and we'd say, whoa, I thought it was going to be in the thousands and my answer's in the hundreds. I must have made a mistake. And then you look back over and you say, oh, I did make a mistake. You look back through every step and you figure out what you did. Well, that's why we make an estimate. And that could help you answer number 9. Estimation can help see if it makes sense, because your real answer should at least be in the same place value as your estimate. I know this is a new method. I know I'm giving you a lot to work on today, and I know your brain needs a break, so I'm going to give you a little humor break. Did you know how many letters are in the alphabet? It is math, right? There are only 24 because E.T. went home. Oh, you don't know that movie? Okay, well maybe you know the Star Wars movie. What is a Jedi's favorite snack? Obi-Wan cannoli. You don't like Italian pastries? Okay, let's move on. This is your study link, and it looks very similar to the pages we just did. They even gave you some space to do your work right down here. So use that space to do your work. So you're going to multiply using the partial product method. Now here's what I want to tell you. I know it's a new method. I know it can be a little confusing. I know it has your parents scratching their heads. When the test comes, you don't need to use this method. In fact, in a couple lessons, I'm going to be teaching you how to do the traditional method, and you'll be able to choose that. Any method that you know how to use is okay and is a good method. You're not going to be forced to master and always use this method. But you never know if you'll like it or if it'll click until you really try it. So today I want you to try it, and if you're totally stumped, if you're scratching your head, keep trying. And if you're in tears and you're throwing your math book across the room, then maybe you want to take a break. And if you know a different method, switch to that. Okay, I'm just going to get you started here. It says to show your work in the grid below, so that's what you're going to do. Number 1 is 56 times 7. We're just going to make a quick mental estimate, and the estimate is going to be 60 times 7, 420. Okay, that's our estimate. In fact, I'm going to do that for all these. This is about 8 times 300 equals 2,400. It's just good to have an estimate. Number 3, that's about 1,000 times 9. It doesn't ask you to write an estimate, but I told you it's a good idea, so I'm not going to not do it. So now 56 times 7, we'll do that down here. 56 times 7. I'm just going to lay this one out for you because I feel like that's what a good teacher does. We're going to do expanded form, turn that into 50 plus 6. 7 is still 7. And then we're going to end up with 2 multiplication problems. We're going to have 7 times 6, 7 times 50. You'll notice sometimes I start with a small number, sometimes I start with a big number. It doesn't matter which, as long as you get them all. So what's 7 times 6? Well, that's 42. What's 7 times 50? Well, we know there's a 0, so there's a 0 there. And 7 times 5 is 35. Line it all up, add it together, and you should have gotten 392. This is for number 1. 392. Look, I did part of your homework for you. And that's really close to our estimate, so I know it's a good answer. You're going to go ahead and do this one. You're going to go ahead and do this one. And then you're going to do number 4. And number 4 is the bigger problem. Oops. Let's get rid of that. Okay. So Maya goes to school 7 hours each day. If she does not miss any of the 181 school days, how many hours will Maya spend in school this year? Well, I'll give you a little hint. That's 181 times 7, but I think you figured that out. Your number model for the estimate, round 181 to the nearest 100. I'm not going to tell you what it is. And then multiply it by 7. That would be a good estimate. But I'm not going to tell you where that goes. Oh, maybe you want to put it there. And then you might want to circle one of these. And then you find out the exact answer by doing 181 times 7 and writing it there. Yeah, there you go. And then number 5 asks a question about the average eye blinking once every 5 seconds. Is that more than or less than 100,000 times per day? Oof. That's a big answer. Well, you need to know how many seconds are in a day, don't you? I'll tell you what. That one's a little complicated. You can feel free to skip number 5. That's not really something, we're not talking about seconds in a day here. You're welcome to try it though. But you've already got plenty of work today. Okay, so you got 4 down here, 2 addition, 2 subtraction. Remember, if the bottom is bigger, double arrow. Always check the sign to see if you're adding or subtracting. I want you to do your math boxes because that's always good review. And turn your study link in to Schoology. Tomorrow, next time, we're going to work on partial products some more, and we're going to add 2 digits to the divisor, so the problems are going to start getting big. So today is the day to get your questions answered, and if you're having trouble, ask a parent, look at that student reference book page, or talk to your teacher. But you can do it. Students for generations have been doing this, and you can do it too. So have fun, and we'll see you next time.